Before we can venture into the world of web development, it's important to have a fundamental understanding of how the internet works, meaning what's happening behind the scenes when we type a web address into our web browser or send a file or email to a recipient. This information will be very useful as we explore the concepts covered in this course. To think of it in its simplest terms, the internet is a network of cables that facilitates the transmission of data packets. The network is extremely vast and spreads globally across 550,000 miles of hidden cables under the ocean to keep the world connected. This snapshot provides a graphical illustration of how complex the network of cables that power the internet really is. A data packet contains the information being transmitted, such as an email, file, or web page, in raw text format, and also the location of the sender and the recipient of the data packet. You can think of the location of a recipient or sender as the physical address of your residence or a phone number. No two residences have the same address, and no two people have the same phone number. The same is true for internet addresses, also known as an IP address. An IP is a string of numbers separated by periods that identifies each computer that is connected to a network or the internet. For example, the IP address for google.com's web server is 74.125.224.72. Each website has its own unique IP address. We'll discuss how this IP translates into google.com later in this lesson. Let's take a look at an example of an email data packet. As we can see here, the data packet consists of three parts. The header. The header identifies the sender and the receiver's IP address. It also specifies the protocol, which we will explore later on. It indicates the payload, which in this case includes the actual email that is being transmitted. Lastly, it includes a trailer, which indicates that the packet is complete and there is no further data for transmission. The speed at which these data packets can be transmitted over a network is determined by bandwidth. Bandwidth transmission capacity is measured by bit rate. The bit rate is the number of bits per second that a digital network can transmit. Another measure of data transmission speed is latency. This is the amount of time it takes for one bit to be sent from the sender to the receiver. Let's take a look at an example. If you want to send a 4 megabyte MP3 file to a friend through an email attachment in 4 seconds, you would require a bit rate of 8 megabytes per second. This is because 8 million bits equals 1 megabyte. Now, with billions of people connected to the internet at any given moment, it goes without saying that the internet is comprised of hundreds of thousands of networks and links billions of devices together globally. With this level of connectivity, you might be wondering how each individual network device can efficiently and accurately interpret and read data packets from various unique senders. While you can think of the internet as an architecture expressed in a set of protocols, a protocol is a well-established set of rules and standards used to communicate between machines. We've already touched on one protocol, the IP. The IP is used to route information to the proper address and make sure that the data packets are sent to the intended recipient. Note that the IP protocol does not facilitate physical connections between computers to transmit data packets. The TCP protocol is intended for that purpose. The TCP protocol makes sure that transmitted data packets are received without any missing information. If it's determined that the data packet is missing data, TCP will request that the sender resends them. Some other protocols that we'll explore in this course include HTTP, HTTPS, SMTP, and FTP.